Okay. Good morning, everybody. I think we're going to go ahead and get started now. It's a little bit after 10, so other people may be joining us later. Welcome to our webinar today. We're going to be talking about plumbing codes. Doesn't get much better than this, does it? My name is Scott Brady. I'm the R&D manager at Prier Products. I've been here about 6 years now, full-time. I actually have been working with Prier for about 15 years, off and on. I work with other manufacturing companies, doing engineering, product development for about 35 years now in industry. Also presenting today will be another one of our engineers, John Nance. He's been with us for 3 years. And also he's got about 10 years of product development experience. There's John and me. Here's an agenda of kind of what we're going to be talking about today. And when we're talking about plumbing codes, there's a lot of codes out there. In particular, though, what we make here at Prier, we're a manufacturer. We make hose-threaded valves. So the codes that we deal with might be different than some of the other products that you specify. So you're probably dealing with lots of codes, but these are the main ones that we're going to be talking about today. And at the end of the session, we're going to have a Q&A. So if you have any questions throughout the presentation, please post them, and we'll take a look at them at the end when we get done. Okay, ASSE and IAPMO. Those are the two main kind of governing bodies, certification bodies that we work with. ASSE stands for American Society of Sanitary Engineers, and IAPMO, it's a little confusing, but they use the UPC shield. So you'll see those are the two main certifications that I think most of the manufacturers use. ASSE has lots of standards. Like I mentioned, we use maybe 4 of them, but the slide says 50 standards. They're coming up with new ones all the time, so they may be up to 60 by now. And one thing I do like about ASSE is they're not just a certification body, but there's lots of different types of members. Some of you may be members, engineers. They have plumbers and inspectors. So it's kind of fun to go to the ASSE meetings because you kind of get the broad spectrum, the full group of everybody working in the plumbing industry together. Now, we primarily use them for their certifications. We want to be able to put their mark on our products to prove to the plumbers and inspectors that our product meets certain codes. Also on the ASSE website, you can just find general information about what's going on in the plumbing industry. They have like a policy hub that looks at regulatory issues that are going on out there. You probably already know this, but a few years ago, IAPMO acquired ASSE, so now they're sort of one and the same. However, the way we work with them, their certification groups are still separate. So we're working with engineers on both sides. Whenever we want to get a product certified, we have to get it tested at a third party, an unbiased laboratory, who then, once they do the testing, they will send the results to IAPMO, then another set of results to ASSE, and we send them drawings and other information, installation instructions, things like that. So we're still working with them separately, but they are the same company, basically. Also on this slide, you can kind of see the CSA logo. Prior, we do not work directly with CSA. We could, but both IAPMO and ASSE have some avenues. If we want to sell into Canada, which we do, we just work through those organizations, and they can help us get the Canadian listing. So they work really with the CSA group. And that's what the little C is next to the UPC shield there. That's not a copyright symbol. That little C means Canada. ASSE has a similar little C that they can put on their mark. Prior, we've just chosen that we work with the IAPMO group on the Canadian listing. So here's the 4 main ASSE standards that we use here at Prier. The first 2, the 1011 and 1052, are for vacuum breakers. 1019, freezes wall hydrants. And 1057 is your sanitary fairing. Okay, so now we're going to do a quick poll. make sure you guys are still awake and learn a little bit more about you. If I can get to the poll here. There we go. Okay, what plumbing code do you base your specifications on? IPC, UPC, ASSE, CSA? Doesn't matter. Maybe you're just happy that it has any type of a code on it. Okay, got lots of votes are in. Like most of you have voted. I'm going to end the poll. Wow, look at this. The majority of you are using IPC. That's very interesting. A lot of you using ASSE, some UPC, some CSA, and a few. You know, it doesn't matter. That's very interesting. Because we kind of in choosing, you know, which codes to use, you're also looking at what parts of the country accept the different codes. And, you know, we've been very successful with the ASSE and UPC. So that's interesting to see. I wonder if maybe some of the other types of products particularly look at the IPC type codes. Now, not all products are covered by ASSE. So particularly IAPMO, they don't have their own standards. So they use whatever standard they think is applicable to the product that you're trying to sell. So a lot of people use the ASME. It's just a standard plumbing supply code, applies to probably hundreds of different types of products. You can kind of pick and choose which parts of the test apply to the product that you're trying to get certified. And also, that's where we find the CSA standards that they use for selling into Canada. And other people are interested in some of the NSF standards, particularly the 61 and the 372, which we will talk about later on in the presentation. All right, here's just your typical vacuum breaker. I'm sure you've all seen these before. Several manufacturers make products. They all look pretty much like this. The two different ones on the left are 1011 type devices. The one on the right is a 1052. The numbers at the bottom, those are just Prier's model numbers, B002, 3, and 4, some of the different types. Now, every vacuum breaker has a backflow preventer in it, and it's a vacuum breaker. So it really has two levels of protection. In the 1052 devices, they have a second check valve. You can kind of see it here on the outlet. So it has two backflow preventers and a vacuum breaker. So it's kind of has three levels of protection. And also a vacuum breaker, when it's sold separately like these are shown, you can see that it has a little set screw in the side. So that once you apply the vacuum breaker, put it on, tighten the set screw, break it off. That way we make sure nobody can, you know, play around with the vacuum breaker or remove it. So you can sell the vacuum breakers separately, or you can put them on other types of products. So here's just your basic silicock. It's been around for decades, probably designed before I was born, but still a popular item. They work great. The one on the far left does not have any backflow protection, but when you put a vacuum breaker on the silicock, like the one in the middle and the far right, now they become a code-approved device. So that's probably what you are looking at when you see a silicock that has ASSE 1011 or 1052, then, you know, this gives us an avenue for having protection on just the basic products. Oops, sorry. Oh, here's a different type of silicock. It's actually one of our newer ones where the inlets are on top and bottom instead of in the back, but same type of deal. You can put a vacuum breaker on there and it becomes a code approved product. Now, we can't just throw a vacuum breaker on there and say, hey, now it's code approved. We still go through the process with ASSE and IAPMO to make sure they have that model number listed, and we sent them all the proper information to get it listed. And 1019, now we're into the freezeless hydrants. So kind of like a silcock, but they have the pipe extending into the building for the frost protection, the nice warm environment. That's really the best way to get these products listed as a 1019 device. Goes through all the proper 1019 testing that we'll talk about here in a minute. But you can actually just put a vacuum breaker on these devices, and it might be listed as a 1011 or 1052 type device. So that's probably kind of confusing maybe to you as engineers. You look at all these different ASSE standards and you see one thing on one product, another thing on another product, and you're not sure why it's listed like that. Really, a lot of the testing is the same. It has to do with, freeze protection in this case, but, backflow and vacuum breaker just to protect the water supply. And then far right, you can see a picture of a sanitary berry hydrant. Those need to meet ASSE 1057. So here's a little picture of kind of what goes on inside of a vacuum breaker. You can see it has a check valve of some sort. Different manufacturers have different types of check valves. Almost all of them have a rubber disc, a rubber washer. So as the water is flowing, the water pushes the washer on against the holes here, sealing them off. And of course, in a backflow condition, it's going to pull the rubber off of the holes so that you have your vent opening there. Typical pressure is, ours are all rated at 125 PSI. I think that's pretty common across the industry. So when they're tested, though, they're tested at twice that pressure. So really they can handle up to 250 PSI. Temperature can go as high as 180. So that's pretty hot. The one on the left, the P002, is bias closed. It can also be a 1011 device and be biased open. So the one on the right, as you can see, it has this is a plastic piece. Again, common, many manufacturers have this, so that when there's no hose attached, it's open. The check valve isn't really doing anything. So whatever you screw this onto, or whatever product you put it on, now it can drain. But once you put a hose on it, it engages the check valve. Product can't drain anymore, so still have to take your hose off to make it drain, but at least now the check valve is engaged. So some people prefer that type of 1011 device. So here's some of the tests that the product has to go through when we send it to the lab. I'm not going to go through all of these with you, but certainly if you have any questions, we can talk about it. One question that a lot of people like to ask is, what is the flow rate? How much water can I get through your vacuum breaker? ASSE, pretty standard across all of their tests, likes to 25 PSI as the pressure drop across the device. So in this case, you have to get at least 6 gallons a minute through it at 25 PSI. But if your building has more pressure, you're going to get more. If you have less, you're going to get less. It also depends on your ability to, you have to get volume of water too. It's not just pressure. It's making sure you get enough water to it. Probably pretty good for that. If you have any questions, like I say, you can kind of see some of the tests that they go through. Here's a picture of actually a cycle tester at QAI. That's the lab that we use. Like I mentioned, we can't just do our own tests and get it certified. We have to have an independent third party. So here you can see where they have kind of a claw on a handle on one of our hydrants, and it has to go through 5,000 cycles under certain pressures, temperatures, allowable leakage, that type of stuff. Now, there's a picture of a 1052 type device. Very similar to a 1011, but we've added the second check valve in the outlet here. So per the standard, same temperatures, pretty much a lot of the same tests. Of course, they have to test both check valves instead of just one. But now they allow the flow rate to drop down to 4 gallons a minute at that 25 PSI pressure drop. So about the same. Okay, time to do another poll. Let's make sure you guys are, oops. Stop sharing. Oh, here we go, sorry. Which ASSE code, I gotta launch it so you can read it. Which ASSE codes do you use in your specifications? Do you like to use 1011, 1052, 1019, or 1057? And while you're voting there, I'm going to turn it over to John. He's going to he'll talk to you about the 1019 devices.
Hello, everyone. I'm John Nance, engineer here at Prier. Let's see here. So you guys are getting some votes in here. It's looking like, let's give about another 10 seconds here to let a few more votes come in. And we'll conclude it here now. Is this your final answer? Okay. So now it looks like, I guess most folks like 1052, but a close second is 1011. Pretty similar there. Now, so these are both the vacuum breaker hose end codes. 1019 and then 1057 comes in last. So let's continue on with the presentation here. Thank you guys for the poll. That was interesting. So now I'll talk a little more about 1019. So this is specific to wall hydrants. And to start, there's 3 different types of a 1019 device, types A, B, or C. So you might notice that, so each of these devices, it's required that a 1019 mark is on the device itself. And it'll have like a 1019-B. Well, that B corresponds to what type of device is this. So in these these different types, they're really just different ways that that the devices can be designed while still, meeting all the code requirements. 1019 device has an operating pressure of 125 psi at a temperature of 140. Now, the 1011 and 1052 products go up to 180 degrees, which they share a lot of the same components. So even though 1019 only requires up to 140, most of our devices can, most of our products can go up to 180. The main criteria here for 1019 is they must be repairable from the front of the building. So it shouldn't require any disassembly of the hydrant, like our 634 here. That packing nut can be taken off. All the guts can be taken out and then replaced. Any elastomeric parts. And then it can have many different inlet styles. So the traditional sweat or MPT threads, and then some of the newer stuff like a PEX, press fit, and push fit. So these are the specific tests that take place in 1019. They follow a lot of the same patterns as what the 1011 and 1052. But they have their own slight differences. So flow rate on a 1019 device is, again, 6 gallons a minute, and that's at the 25 PSI differential. Now, this one does have a freeze test, that it must sit in a freezing condition at 0 degrees Fahrenheit, and then it must flow again after this condition. And then here at the bottom are our our safety precautions. So the vacuum breaker, testing the backflow preventer, that type of stuff. So here's one of our devices being tested. This is actually it's either 1011 or 1052 device being tested at our third-party testing facility. So all these ASSE tests have to be done by a third party and verified that way. So we can't perform our own test. So this here is measuring the pressure at the inlet of the device and at the outlet of the device to get a pressure differential. And then a flow rate here is given. And what this will, sorry, making you guys dizzy here. And what these flow tests will produce is a flow versus pressure curve. So you can see here on the left that's our flow in gallons per minute, and at the bottom is the differential pressure. So these are different flow rates captured at each of those differential pressures. So of course, ASSE, they really care most about the 25 PSI differential. And you can see here for 634, it's just over 15 gallons a minute. Now ASSE uses that 25 PSI differential as their standard to get away from, some buildings will have higher pressures. So as you can see here, like a 30 PSI differential will obviously produce larger flow. And same for less pressures, less flow. So they've decided to use 25 PSI over all their devices. So this is this product being freeze tested once again. And they do set these up, pretty realistically. So this is a device in a cold chamber, and the head of the hydrant is inside of the cold chamber with the freeze, the body of it that would be back into the warm section of the building. That is, outside of the cooler. So that's held at 0 degrees, and then after it sits for an hour, it must flow again. So now moving on to 1057. If you have any more questions about 1019, just post a question there, and we can answer them here at the end. So 1057, away from wall hydrants, these are particular to sanitary yard or roof hydrants. Similarly, they have different types. So these are types 1 through 5. Some can have 2 check valves. It can have 1 check valve. The tests stay pretty much the same, but they'll have specific nuances between the types that must be checked, depending on how the components are being used inside. These hydrants are up to 100 PSI, so a little bit less than 1019, with a temperature of, once again, 140. Now, the same requirement of it has to be, serviceable without excavating the hydrant. So, for instance, on our ground hydrant here, this cap can be taken off. All the guts will pull out of the middle once again, and then you can replace any of the rubber or elastomeric parts underneath without excavating soil or removing it from the roof, any of that kind of thing. So a little bit more into the physical tests. Once again, they follow kind of the same main points that we're trying to cover. The flow rate here for a Berry hydrant or a roof hydrant is a little less at 4 gallons a minute. Now, the main difference here that separates 1057, it's called a sanitary yard hydrant. That is taken, or that takes place here in the freeze test itself. So it's still the same setup that it has to maintain in a cold chamber at 0 degrees and then flow afterwards. But one of the main failure criteria of this is that it cannot drain below the ground line or below the roof line. All the drain water has to be contained within the hydrant itself. So we'll talk just a little bit more about that here and what that means. So for on the far left is our P260. That's a traditional ground or Berry hydrant. or a roof hydrant to, as it flows out the hydrant, of course, and then whenever it's turned off, this drain water that's in the upright drains down and comes out a weep hole here at the bottom, of course, and drains either underneath the ground, or if it's in a roof setting, that drain line has to be run to a drain somewhere, sometimes close, sometimes far away. Can cause some issues there. Now, these 260s, a traditional, roof hydrant or a ground hydrant, it can still be code approved, but it'd be more to like a 1052 or 1011 type of an approval. Whereas, so a sanitary 1057 device would be like our PRH4. And you can see here that it's set up to where it has this canister that's underneath the, in the warm part of the structure or underneath the ground. So once again, it'll drain all of its water from the upright and come down and drains into this empty canister. And so all that water is contained within the, the device itself. So then whenever the hydrant's turned back on, this piston comes down and purges all the water out of that canister back into the stem. And it is actually the first to leave the hydrant as well. So we like that about the device is, the water that sits in the can and is, kind of just hanging out there until the next time that it's used, it's actually the first to leave the hydrant too. So the second way that's commonly, that this is commonly done is through a venturi. So once again, you have a water reservoir underneath the roof or in the ground, and all the drain water collects in that. But then instead of a piston pushing, pushing this drain water back out, it's done with the flow through the hydrant, creates a venturi vacuum, which then pulls all the water from the reservoir, and it drains the canister that way. So the main difference here is that a venturi needs to be winterized. So it has to go through a procedure that it must flow for a certain duration to make sure that the venturi is fully emptying that reservoir so that whenever the hydrant drains, it has a full capacity of a reservoir to fill back up. Otherwise, if it's turned off too soon, it can become waterlogged and therefore not freeze resistant anymore. So whereas the piston, there's no need to winterize that. Every time that it's turned on or off, it completely clears or completely fills the canister. So let's ask another question here. Keep you guys engaged and see what your thoughts are about roof hydrants specifically. So when specifying a roof hydrant, do you all prefer a model that drains or one that doesn't drain? And I guess that question by no drain, it would be more like a 1057 device that, it would still be freeze proof. Sanitary. Yeah, but it would be sanitary and it would be contained within the device. All right, so we'll give about 10 more seconds here. All right, we'll end the polling and show you guys the results here. So it looks like about 2/3 of you prefer to drain and are okay with running a drain line and going about it that way. So whereas about 1/3 no drain. Okay. Well, so in that case, we have hydrants that work for both of those. So the P260 would be one that you would go ahead and run a drain line from. It could still be approved with a 1052 or 1011 device. So both work there. Oops. So just a real quick touch on roof hydrant mounting. So some manufacturers will mount with a mounting flange that'll mount to like the roof membrane or the roof skin So it can be mounted anywhere on the roof, but it is relying just on the roof itself, just the skin to create enough rigidity to hold everything in place. It does take a few more penetrations through the roof to mount this as well. So typically 4 bolts and then the main penetration for the hydrant. So our mounting device here is actually rigidly mounted to the structure beneath the roof. So it's mounted really to the building itself, not just to the roof skin. And then through this mounting bracket, we can mount the hydrant to, and then that makes for just a single penetration through the roof, so less leak points as well. So just want to touch on that quickly too. So we've covered all the ASSE codes, but once you get the initial approval, it doesn't end there. ASSE continually checks up with their manufacturers to ensure that the products that were approved still can be approved and maintain their approval. So they send annual audits and auditors they come and inspect the plant. They take them, our folks will take them on a tour. They'll talk with the production team. They like to talk with the quality team. And then at the end, they'll take back a few samples back to their labs and then test a few of the actual ASSE tests just to verify that the products that were once approved still maintain and and still have those same safety measures and flow rates and all that stuff. There is a cost associated with this. So the initial cost is there whenever the product's first approved. And then there's an initial or a continual cost of around $12,000 a year to keep up to date with these codes. So just a little tidbit there. Now, past ASSE, there's a few other codes. Scott mentioned like ASME, some ANSI codes that they'll use for like the threaded connections and that type of stuff. And past that, so lead-free is another topic that that our customers and engineers are concerned about. And NSF 61 tests the contaminants in the device after. So it's a physical test. So the hydrants are filled with water. This is just one sample of a test, but it's filled with water, and then it sits for a while, and the water is then tested after to see how many contaminants are leached out of the device. This can be pretty expensive too, but does give good information and protects, in essence, our water supply. Now, 372, NSF 372 pertains just to lead content, and it's a calculated measure that is, it takes into account the wetted surface area of the product, so all the components inside of the device that are wetted, and then we calculate the lead content of the material of each of those components, and then so that maximum average of those has to be less than 0.25% to be considered lead-free. So, and many of our products are. So, well, thank you guys for your time today, and I'll turn it back over to Scott.
Thank you, John. Good job. Here's a slide that gives you a little bit of information about Prier. We've been around for quite a while, and so John and I are in our R&D department, but we do have other engineers that work here as well. We're members of ASPE, as probably many of you are. In fact, ASPE show coming up here in a couple weeks, so hopefully you guys plan on attending that. It's going to be a little different this year, being done virtual, but please stop by our booth, check out all of our products, and I hope to see you there. This presentation will be sent to you within the next 24 hours. So if you found it interesting, there's information in there that you can share with your colleagues, great. Feel free to do that. Sometimes we just talk to engineering firms one-on-one. So if your firm maybe has more specific information you want about a certain standard, we'd be happy to talk to your group along those lines as well. Now, as we promised you, there was a $100 gift card to Bass Pro Cabela. And, oh, we do have a Q&A coming up also as well, but, well, I'm going to hold off on the gift card until we do the Q&A. I'm going to keep you hanging on just another second longer. Let's see what kind of questions we have out there. I know you're all on the edge of your seat right now. So there's a comment. They use a different standard in New Jersey in NSPC. I've actually never heard of that standard. Maybe you have to look into that. It probably pertains maybe just to New Jersey. Here's a question. Are Prier freezeless hydrants lead-free, or do they need to be? Well, all of our hydrants are made for irrigation use. So there are laws, regulations out there that plumbing fittings and supplies need to be lead-free, but our particular products are exempt because they're for irrigation use only. They're not meant to be, people aren't supposed to drink out of them. They probably do, but they're not supposed to. So most of our products are not lead-free. We do have some that are, though, because some states, cities, jurisdictions require lead-free. So, of course, we want to sell product in those areas, so we have some versions that are lead-free. The new sanitary barrier will be lead-free. Third question, which code is better, single check or double check? I suppose that would be kind of a personal preference. You know, how many levels of safety do you want to have on a product? As we were talking about, single check, really there's two forms of protection even in a single check device. You have the check valve and the vacuum breaker. And of course, the double check is even another level of protection. You're kind of banking on, you know, what are the odds that you're going to have a backflow condition? So maybe it depends on the application of that type of product. Here's a question. What's the highest flow rate in a wall-mounted freeze-proof hydrant Prier has? Well, the highest flow rate would be the C634. It's a commercial hydrant. In fact, John showed you the flow curve, so that is our highest flow rate product. At 25 PSI pressure drop, it's around 17 gallons a minute for the flow rate. Most of our residential hydrants are, you know, the minimum that we have to meet is 6 gallons a minute. Most of those are like around 7, 8, but we want our commercial products. They're big, bulky, solid. We want them to get at the highest flow rate possible. Wow, lots of questions rolling in here. Wouldn't it be better to have a roof hydrant without a drain? Why would some engineers prefer a drain? Good question. A lot of it might depend on, you know, how far from a drain are you? How long do you have to run the drain line? And it costs money to run drain lines. I've heard, you know, lots of different numbers that engineers have thrown out. So in some cases, it's just cheaper or easier just to put a sanitary hydrant in. Now, I've also heard, though, that some engineers don't want a sanitary type hydrant because that water may sit in that canister for long periods of time until it's used. So they kind of worry about things like Legionellas and, you know, what's going on inside that can. That water's sitting there. So they just want all the water out of it. Okay, let's see. I think somebody's asked about a hydrant with an outdoor shower. Well, okay, we do have a new product that has an outdoor shower. I don't know, as far as an engineering specified type product, it's probably more along the lines of our residential type products. We have an outdoor hot and cold hydrant. A lot of people like it. It's been around for decades. And people have asked us, hey, could we hook a shower up to your product? And people have rigged up some interesting things to it. But so anyways, we decided to come out with one that you can just buy, basically a shower rod, and attach it to the product, even an existing product. That's probably it for now, I'd say, on questions. If any other questions come in, feel free to, you can contact me directly, or if you want to, we can hang on afterwards and maybe answer some more questions. But I think you guys have been on here a long time now, so we probably need to wrap this up and do the drawing. So we're going to do, close that out for right now. Let's do the drawing. Okay. Somebody has selected the winner here. It's not me. I am an unbiased participant. The winner is Michael Kopp with ESI Group. Congratulations, Michael. You win the $100. Yeah, applause, please. Bass Pro gift card. So we will be contacting you and getting that to you as soon as possible. Again, thanks for all attending, and hope to see you at the ASSE show. Have a great day.
You want to answer those other questions?
Oh, I guess if there's anybody still on, we can, how do we get back to Q&A? Oh, Q&A. There's a few more questions that were coming in, so. So still back to the, I'd say, sanitary berry question. Somebody has asked, they have a concern about standing water and health concerns, so they believe that draining is needed. So, yeah, just like I kind of mentioned, some people are worried about that. I mean, that water could sit in that canister for months. As John mentioned, at least depending on which type of sanitary berry you have, our type, that's the first water out, and once it's out, it's gone. With the Venturi type, it takes, say, 30 seconds or so to pull all that water out. So your first 30 seconds or so of water might be contaminated or not the best water. So draining is great. It's a simpler hydrant. Less things to go wrong. It costs less. So it probably just depends on how far do you have to run that drain line to get to it. I think that's all of our questions. Again, thank you everybody for participating, and we'll see you at the ASSE show.